Okay, I want to show y'all a few things here, and this is on quantum physics. Alright, so this, let me flip it around here, and then I'll show you, I'll start with this right here that I've been watching. Okay, this is on Amazon Prime, The Many Hidden Worlds of Quantum Mechanics. This has one season. So this is really good on explaining the quantum physics and quantum mechanics. It helps give you an understanding. You don't have to know all the mathematical part of it. Just stuff like this, learning things like this will help give you a basic understanding. So it helps with understanding. So like all this math stuff, you don't have to know all that and worry about that. He goes over a little of that. Okay, so this guy's name is Sean Carroll, and he explains a lot of the physics here on this show.
This course is going to explore a truly mind-bending idea that quantum mechanics, which is our most successful framework for doing fundamental physics, has a remarkable implication. It predicts the existence of a large number of separate universes parallel to our own, almost identical to the one that we live in, but with small variations between them.
See, so what he's talking about here,
as the many worlds interpretation
this is quantum physics.
The first thing to say
it's not something that somebody just made up and started saying there's other dimensions.
It's a full-blown scientific theory. We talk about interpretations when we have some kind of specific thing in front of us, like a text, a novel, a work of art, and we're asking, what does it mean? That's an interpretation. Back in the old days of quantum mechanics, so the first decades of the 20th century, this used to be something that was thought to be needed when it comes to quantum mechanics. We had some rules, we had some principles, we weren't really sure what it all meant, how to think about it, how to interpret it. But these days, we know better. We're in a different situation. We have several competing, honest scientific theories. They all make similar predictions to the old rules of quantum mechanics, and we're trying to decide which of them, if any, is the correct one. What we're doing here is science, not literary criticism. The idea that there are many universes parallel to our own, that's a dramatic claim. You have a right to be skeptical at first. I'd be disappointed if you were not initially skeptical. But I'll try to explain why physicists have been led to such a wild conclusion. And importantly, it is a conclusion. It is not an assumption. We'll see how the very simple and innocuous postulates of quantum theory lead us directly to the existence of these other worlds. The postulates could of course be wrong, but then you gotta say how you're gonna change them if you think they're wrong, and it turns out that changing them is tricky. Many of us believe that the best theoretical approach is simply to accept the prediction that the basic postulates make. Not everyone does, there's no consensus, at least not yet, but Many Worlds is one of the leading contenders for a rigorous underlying formulation of quantum mechanics. So in this lecture, the very first one, we're going to briefly summarize this dramatic punchline, and then we're going to back up just a little bit, try to justify how and why we got there. So let's start by getting the basic idea on the table. What is...
Okay, so what I'm trying to do here, hopefully they won't flag me on this. I'm going to try to put what he's saying in here. And if they flag me, then I'll go back and change it. But that way you can hear it from somebody else instead of just me too. You can hear it from somebody from a university. and why he's explaining why there are different dimensions and why it's part of quantum physics. And he was saying, he talks about how nobody just came up with this and made it up, that doing the quantum physics, doing the math, it forced the dimensions and stuff onto the physicists. It's not something that one of them just wanted to make up.
Quantum mechanics. It's a framework. It's a framework for doing physics. It's a replacement for classical mechanics, which was the incredibly successful framework established in the 17th century by Isaac Newton and others. The big difference between it tells a radically different story. Unlike classical mechanics, in quantum theory, at least according to the textbook version that we teach our students even today, we do need special 50s. A graduate student in physics named Hugh Everett started reconsidering the foundations of quantum mechanics. He developed what he called the theory of the universal wave function. In that picture, every possible measurement outcome actually happens. The secret is, each one happens in a different world. This approach was later, not by Everett but by others, dubbed the many worlds interpretation. As we'll see, the worlds of the many worlds interpretation come out of the equations. They are not put in by hand. They are a prediction. They are not part of the postulates of the theory. Many worlds is a very specific and quantitative theory. It's not a vague idea that just says, it's quantum mechanics, anything goes. It makes predictions, there are equations, everything you want from an honest scientific theory. So let's think.
Alright, so see what he's saying here. This is not just something that somebody decided to make up one day. This is all part of quantum physics. Alright, so I'm going to put the link in here to this. And I got another couple parts here I want to try to show you here in a few minutes. And then I'm going to put the link to this in here too in this video. I'll put the link to this in the description. So this is a part where he's talking about the space-time and space-time being warped. So he also talks about the light spectrum. So he's showing like a graph here where it shows the different light and stuff here. It's similar to one that I show. I have one that I show quite often that talks about the light spectrum. It shows all the different kinds of light, including the radio frequencies. Like we listen to the AM and the FM radio frequencies, or we listen to the AM FM radio stations. Okay, so I have playlists on my channel. I have a quantum physics playlist, and I have a frequencies playlist. If you want to check those out, those will help give you some understanding of what's going on with this, and also some books I've been reading. So this is what I started out with, The Quantum Bigfoot by Ron Moorhead. So this is what really got me interested in realizing that there's something going on with the quantum physics and explaining what's happening here. So that's a really good book. He spent 2 years researching that before he wrote it. And then some other books you can get. These are really good. This is Basic Quantum Physics. So to help give you a really good understanding of just the basics. And like I said, you don't have to be like a math whiz and worry about all the math and that. It's just getting a basic understanding of what's going on with the quantum physics and the light spectrum, things like that. This is another really good book. So this is another really good book, The Field by Lynn Taggart. This is really good too. She's a journalist and she spent a lot of time with some quantum physicists and trying to explain what's going on with the quantum physics. So this is really good. So on my playlist I have quantum physics videos, frequencies, so these will all help you, give you a basic understanding of quantum physics and explain some things here. And some of these are frequencies that I've been using to do my experiments. So I'll put the link to these in the description also.